All right, this is AP Calculus AB. I'm talking about worksheet 11-1. This is the key to success. Okay, so this is going to be number 1 off here to the left. I have my calculator. We will need calculator on the front side and not on the back side. Back side is purely no calculator. Okay, so number 1, R and S are regions A. This is almost the exact same thing that we were doing, only it's cosine instead of sine for the notes. Find the area of S, and we're not going to find the area of R apparently because it doesn't tell us to. Interesting. Okay, so just S. So S is going to be equal to, so I have to split this function in half, right? Because I have area underneath one curve, which is our y equals x function, and then area beneath another curve, which is our cosine function. So I have two different functions happening here. Those are, I can make those lines look slightly better because I'm going to hold on to those lines. So S is equal to our left piece, which is x, so it's going to be the integral from 0 to wherever that intersection point is. And I have to figure out where is that intersection point, this black line. So I come into my calculator and I say, let's get rid of all of you. My y equals, I'm going to have clear all of that. That's just going to be x. This is going to be cosine of x, good. And then I'm going to do zoom 0, and then I'm going to find their intersection by doing second trace to calculate, I think it's 2 the intersection, or maybe it's something else. So I'm going to do go. Second trace, and oh, it's 5 for intersection, and my first curve is that one, second curve that one. You can always just hit enter whenever you're doing intersection. It's a quick way of doing it. You don't have to hit up or down between them because there's only 2 functions. The only reason they have you select the functions is in case you have more than one function or more than 2 functions graphed here. My guess is about 0.8. And my answer is 0.739. So I'm going to write over here 0.739. We are going to need to know this n bound as well. And if you know the cosine function, you'll know exactly where that is. It's pi over 2. If you don't know that, again, you could come over here and say, what is second trace to calculate the 0, so 2, which curve am I on right now? That's not the right curve. Hit down, and I can get onto the right curve. Now I'm on the right curve, and I'm going to say my left boundary is 1, my right boundary is 2, and my guess is about 1.5. And it should get 1.571, so this is, I'll say over here, or 0.571. Oh, I said 1.571. Why am I saying that? 1.571. Okay, so coming back to our integral, this is integral between 0 and 0.739 of the blue function, which is our x dx. And then we're going to add our red function, so plus the integral from 0.739 to pi over 2. Pi over 2. And that's going to be of cosine of x. Oh, what happened there? Cosine of x dx. All right, and then we can just enter that in on our calculator all at the same time. So second mode to quit out of all of that. And let's do it. So math 9, integral between, or integral of, I guess var is right, enter. You don't have to do that. You could have just typed in x here and it would have been the same thing. From 0 to 0.739, and that's going to be, oh shoot, I forgot to do with respect to, so I have to come back here, second delete to insert with respect to x, comma, okay, now I've inserted everything. So I'm not going to throw me any errors. That thing plus math 9, the integral of, I'm just going to write cosine of x here instead of var's right, enter 2. So cosine of x with respect to x from 0.739, comma, and I can do the decimal approximation or just do pi over 2. So second pi divided by 2. Cool. Adding those two together, I should get 0.5995, and that rounds to 0.600. So come back here and say 0.600. Final answer and box it. All right, and we don't have to find R, just S. So on to number 2. Find the area of R. All right, so, and I have a feeling that finding the area of S is going to be tomorrow's lesson. I am now realizing that's a mistake. Oops. I taught you too early. Too much, too early. But I think you guys got it. So finding that area R, I have to split it into two sections because one is below tangent of X. So I'm going to say that this blue area here is beneath tangent of X, and this red function over here is beneath 2 minus X cubed. So I have to find that intersection point, and I also have to find this endpoint as well. Where does that intersect? And it's probably going to be the cube root of 2, because if I plug in the cube root of 2, I'll get a height of 0. So I'll just write that down now. This right there is the cube root of 2. And I'll have the decimal approximation in a sec, because I don't know that off the top of my head. So what is the cube root of 2? So to do the cube root, you can do math and come down here to 4, or you can do any root with 5, but I'm going to do 4. Cube root of 2 is approximately 1.260. 1.260. And that intersection between tangent of X and that function, I don't know, so I'm going to come here to go y equals, get rid of both of those, clear, clear. My first function is going to be my blue function, that's tangent of X, so I'm going to type tangent of X. My second function is 2 minus X to the power of 3. So I have the two functions. My window is going to be between 1 and, I don't know, 1.4. It doesn't really matter. I'll do 1.5. 1.5 and zoom 0. Again, you want your window kind of close to whatever this point is, because this tangent of X goes off to infinity. It hopefully will know that, and it's not going to go up too crazy. There's tangent, and yeah, okay, so I have my two functions. There's their intersection point. Let's figure out what that is. So I'm going to do second trace intersect 5. First curve, enter, second curve, enter. My guess is about, I don't know, 1. And I get 0.902. So I'll say this is 0.9, did I say 902? Mm-hmm. 902, okay. All right, so now that I'm actually finding this area, okay, I'll get back to it later. This is now going to be the integral. I can do a slightly better integral. Integral between 0 and 0.902 of our blue function, and that is going to be our tangent of X. Tangent of X dx, and I guess I can make all of this blue to kind of color code this better. And then I'm going to add that with the red, which is going to be the integral from, my integral symbols are getting worse and worse, integral from 0.902 to the cube root of 2 of the 2 minus x cubed function. 2 minus x to the power of 3, all that stuff, dx. All right, enter this all on the calculator, and you get 0.729, 0.729, rounding correctly. If you want to see how to do that, let me see if I can pull that up really quickly. Second mode to quit out of this, clear out of that. It's going to be math 9. It's going to be my tangent function. So I'm just going to type it in, it's faster. Tangent of x with respect to x from 0 to 0.902. And the parentheses plus math 9, the integral of 2 minus x to the power of 3 with respect to x from 0.902 to the cube root of 2. So I'm just going to do the decimal, 1.26. Hit enter. I don't need that last parenthesis because it knows what's going on. And 0.729 is the right answer. That was question number 2. I'm on to question number 3 now. Find the area of S. So S, again, I'm dividing into 2 pieces. So yoink, right there. Where's that intersection point? Well, they have them labeled down here. It's hard to tell which one is which. Know that 2 to the power of x is always going to be going up and up and up. That's an exponential. So I'm going to say 2 to the power of x. That's going to be my blue function. 2 to the power of x is this one that goes up and up and up and up. So this is my blue function right here. My red function is going to be the negative quadratic. Negative quadratic, again, it's a rainbow. It's not a smiley face. Smiley face is a positive, but this one is a negative. So I have a rainbow here. And that's going to be, I'll label this 3 minus x to the power of 2. Cool. So I need to find that intersection point and this intersection as well. I guess I could solve this one. What is that going to be? if I set that equal to 0, it's going to be the square root of 3 for that point right here. Just doing that in my head, that's the square root of 3, and then we'll get the decimal approximation. I think I'm doing that right. So if I plug in the square root of 3, then square that, and then minus 3 is, yeah, so that's 0. To find this intersection, I don't know how to do that. You have to do it graphically. So clear, clear, oh, clear, clear. This is going to be, my first function is 2 to the power of x. My second function is 3 minus x squared. And my window is going to be about 1 to 2. So window, I'll just change this to a 2. And zoom 0. While I'm doing that, I can do square root of 3 is about 1.732. I knew the first decimal, 1.732 though. So 1.732. So I have our graph. It looks very, very different. Oh, that's because I don't have the left-hand side, which is fine. I'm only finding S, so that's why I have my window out to the right, which I think is fine. And to find that intersection point, I'm going to do second trace to calculate the intersection. So 5, first curve, enter, second curve, enter, guess, yeah, sure, right about there, just hit enter. And the intersection is exactly at 1. And the height is 2. That's a really nice point. So I plug in a 1. 1 is the x coordinate. All right, and then finally, we're going to do some of our integrals down here. So first I'm going to do my blue function, integral between 0 and 1 of 2 to the power of x. So come down here. This is going to be equal to the integral between 0 and 1 of 2 to the power of x dx. And then I'm going to add that with my red function, which is the integral from 1 to the square root of 3, 1 to the square root of 3 of this 3 minus x squared, that quantity d of x. Okay, we do this on the calculator, and we should get 2.240, 2.240. Let's see if we actually can do that correctly. So I'm going to go second quit, and I'm going to do math 9 integral of this 2 to the power of x with respect to x from 0 to 1 plus math 9. It's going to be probably faster to go vars right, enter 2 with respect to x from 1 to 1.732, and hopefully get 2.240. There it is, 2.240. All right, that was number 3, and now we're on to the backside with no calculator, but there's a bell. Nope, bell didn't come. Weird. Okay, well, I'll do this video in a sec. All right, I'm back. When I was looking over my notes, by the way, for the backside, I noticed that the last 2 problems, you definitely need to use a calculator. There's no way to do those without a calculator. I think 5 minus x. Yeah, because you don't know what the intersection between them is for this one down here. Like, where does that happen? You have to set this equal to that, and then how are you supposed to solve? I don't know. I mean, maybe if I thought about it longer, I could solve it, but I'm pretty sure a calculator is the way to go. So this was number 4, and definitely without a calculator to get some practice here. So it gives us the intersection, which is kind of the reason that we don't need to use a calculator. We are trying to find the area of R, so between 0 and 4 of f of x, and f of x is the square root of x, and that seems pretty easy. Okay, so let's just do that. So I'm finding that blue area, and that's going to be the integral. I can write slightly neater. Again, zooming in makes it look like my handwriting is nice and neat. This is the integral between 0 and 4 of f of x, which, as they just said, was the square root of x, or x to the 1/2 dx. And from there, I'm going to just take the integral, the integral. So antiderivative, this is now equal to x to the power of, it goes up a power, 3/2, and then divide down, so 2/3, and evaluation bar between 0 and 4. So from here, what are we going to do? We're going to plug in 4, so 4 to the power of 3/2, we'll do some scratch work. 4 to the power of 3/2 is the same thing as 4 to the power of 1/2 to the power of 3, which is equal to the square root of 4 to the power of 3, which is equal to 2 to the power of 3, which is equal to 8. All right, so when I plug that in, I get 2/3 of 8, and I guess the 2/3 can be factored out. And minus, when I plug in 0, 0 to the power of 3/2 is 0, and then so I can say it's minus 0. And then finally, for my final answer, Okay, thank you. 2/3 of 8. 2 times 8 is 16. 16 divided by 3. Can't really reduce that, so I'm just going to leave that as 16/3. So 16/3. And that is only the left-hand piece. So again, we kind of arbitrarily wrote a line right there to divide it up, but we're trying to find the entire region, right? So I found this left region. Can I do Command-Shift-C to redo that? No? Okay, well, I will just try it again. So this left-hand region, therefore, is 16/3. But what is this right region? Well, it's kind of easy. It's a triangle. But if you wanted to use an integral, you totally could. I'm not going to. 4 to 6, that's 2 by 2. 2 times 2 is 4, and then half of that is going to be 2. So it has an area of 2, just knowing that it's a triangle. So to find the entire area of R, I have to do that plus 2, so a little bit more scratch work. So 16/3 plus 6/3. Again, where did 6/3 come from? That's 2, right? I'm adding 2, and that is going to be equal to 22. What am I doing? 22/3, and that is my final answer. Then we are on to part B. Oh yeah, so part B, this is hard. This is like a typical type of like AP question. But if you know the stuff from part A, you are getting the majority of the points. You're passing the AP test. If you really are shooting for a 5, you might want to learn how to do part B. So I'm going to call this the bonus round. Bonus. So on this guy, we're trying to find the graph, or the point P at which the graph F is, or which the line tangent to the graph is perpendicular to the graph of G. Okay, so what is even going on here? We have F and G. Point P on the graph of F means somewhere on this line I'm going to have a point where the line tangent to the graph of F is perpendicular to the graph of G. So perpendicular means that it, in terms of G, perpendicular to G means I have a 90-degree angle right here. So where do I have this slope? Like if I drew that line perfectly to demonstrate, technology, go! Perfectly, it should look roughly like that. If I drag this line around, where's that line going to be tangent? And it's going to be tangent right about there. So I know it's going to be about a half. So at this x-coordinate right here, I'll have a line tangent. How do I figure out exactly what are the x and y coordinates? Because it's finding the coordinates, both x and y, of this point P right here. So I'll call this point P. All right, so, well, first, what is the slope that I'm trying to find? I can find that right away because I know the slope of that line. So I'll type this out as well, just in case we forgot. Perpendicular perpendicular to G means and I'll put, I don't need to put quote, the opposite reciprocal of the slope. All right, so what is the original slope? So this slope is clearly -1 because I go down 1, right 1, down 1, right 1, I intersect. So it has a slope of -1, and I'll put over here, slope is -1. Slope, all right, is, so I don't confuse, is -1. So the opposite of -1 is 1. Opposite just means multiply by -1. So opposite means multiply by -1. So I don't know. So times -1 times by -1. And 1 times -1 is obviously 1. And then the reciprocal of 1, well, 1 is 1 over 1. So if I flip these, it's still 1. So the opposite reciprocal of -1 is 1. So we found the slope that we're trying to find. So we'll say slope. How do I say this? We'll say that this implies slope. I know I need to write neater and nicer. So this is implying that the slope at P is 1. Okay, so far so good. That means that if I take the derivative at P, I'll get that equal to 1. So I'm saying that, and I'm doing F right now. So if I take F and I take the derivative, F prime of X, I know that that's going to be equal to 1. Well, how do I do that now? What is f of x? F of x is square root of x. And I took the, well, I haven't taken the derivative yet. This is the same thing as x to the 1/2, right? I'm going to take the derivative of x to the 1/2, and then I'm going to set it equal to 1, just like I wrote right here. I'm taking the derivative of f, setting it equal to 1. How do I do that? Well, let's see. Showing my work here. I'm going to say d dx, the derivative with respect to x of x to the 1/2. We're going to set that equal to 1. And the derivative of that is going to bring down the 1/2. 1/2 x to the power of negative 1/2 is equal to 1. And therefore, 1, I don't know why that always happens, 1 over 2 square root of x is equal to 1. All right, so now I need to do a little bit of algebra solving voodoo. So I don't know why I said voodoo. I'm going to cross multiply. Or alternatively, I'm really dividing by 1. I can just switch these diagonals. That's a quick way of doing it. So switch the diagonal, and I get 2 square root of x is equal to 1. And I guess I'm really just cross multiplying. Dividing both sides by 2, and I get the square root of x is equal to 1/2, and then square both sides. So I'm going to take that side and square it, take the right hand side and square it, and I get x is equal to 1 squared. 1. 2 squared, fourth. X is 1/4. So if it seems like we're done, you're close. It's half of it, right? We're trying to find the coordinates, plural. So we found the x coordinate. I need to find the y coordinate now. So how do I find the y coordinate? Well, lucky for us, lucky here. Lucky for us, we have a function that says, hey, my y value, I just take the square root of whatever you gave me. So what's the square root of 1/4? And we just wrote it up there. It's 1/2. So the correct coordinate, and I'll write down just to show how that works. We'll say, what is f of 1/4? Well, that means I'm plugging in the square root of 1/4, and that is equal to 1/2. So the final answer here is, I guess, y is equal to 1/2. My final answer is 1/4, and I like writing my answers in red, 1/4, 1/2. That is the point at which, the point on f at which we have a slope that is the perpendicular, or a slope that is perpendicular to the graph of g. Whew, and I guess I should box that. Yeah, definitely a bonus question. Not something that we typically do on the homework. All right, so these ones we're definitely going to use a calculator. Let me fix that. I have technology. You guys can try to hand draw this, but it's probably a little bit hard. I'm going to copy paste this calculator down here. Zoom back out and pasty right there. Aha, no, we know it's a calculator question. And I'll make a note for myself next time. Fix this. Shift, spacebar. If you hit spacebar, it zooms down, right? Fix this for 2021, for the next year. Let R be the first quadrant bounded by the, let be in the first quadrant. So this is in our first quadrant bounded by the x-axis, the graphs of natural log of x, and 5 minus x. So 5 minus x is the linear function. So I know that the 5 minus x is this one. 5 minus x is our line, and then therefore the other one must be natural log of x. Natural log of x. Good, and that makes sense because natural log of x comes down and down, closer and closer to that y-axis. Everything's looking fine. Find the area of R. Again, I'm dividing R into 2 regions here, so there's the line, and I'm going to add the left region plus the right region, and I will have the answer. So, how do we do that? Well, I'm going to find this area for the natural log of function, so this area right here, and then I'm going to add that with the red function, 5 minus x over here, but I have to find this intersection point, so let's find that now. Pull up our calculator, let's clear out of view. Is it on? Turn on, and then clear. Y is equal to clear. I'm going to say that this is natural log of x, and this is going to be 5 minus x. Second quit window. I'm going to guess this 1, 2, 3, 4, 5. So I'm going to go out to 5, sure, and then zoom 0. What do we got? I'm sure it's going to go up and up forever. Up into the, not up forever, but quite a bit taller than it is on this graph. Yeah, I'm just talking about that tiny region there. That intersection point, I'm going to guess, is 1, 2, 3, 3 3/4, or 3.5, I guess. So second trace to calculate the intersection 5. First group, enter. My guess is about, what I say, 3.5, 1, 2, 3.5, yeah. 3.5 is my guess. I'm going to guess 3.6. Yeah, oh, I was closer with 3.7. So 3.693. Let's write it down here, too. 3.693. 3.693. If I keep saying it over and over, maybe you'll remember 3.693. 3.693. And then from here, we're going to write out our integral. So my blue integral, the integral on the left, is the integral between 1 and 3.693. Yet again, of this natural log of x function dx. And then I'm going to add that with our red function, which goes from 3.693 to, that's going to be 5 to 5. And that makes sense because 5 minus 5 is 0, the height of 0. So there's going to be the integral from 3.693 to 5 of 5 minus x, that entire function dx. And again, this is just something that you enter on the calculator, and then you are done. So how do we do that? Let's second mode quit out of that. I'm going to do math 9, the integral of, I'll just type it in again, natural log of x with respect to x from 1 to 3.693. Oh, I don't need to do a comma. I need to do a parenthesis. Then I'm going to add that with math 9, the integral of 5 minus x with respect to x from 3.693 to 5, and hit enter. And my answer key is telling me 2.986, and I did not get that. What did I mess up on? Natural log of x, 5 minus x, 1 to 3.693. Dang it, I didn't enter in my calculator. So I can hit second enter and just come back. 3.2 delete to insert 3.693. Okay, now we should get the correct answer of, there it is, 2.986. 2.986, final answer, and box it. B, there's a point P. Oh boy, is this one of those hard ones again? Point P on the graph of natural log of x. So on this blue graph right here, there's some P, I don't know where it is, but we can move this point somewhere on this line. So where's that point P going to be? It's perpendicular to the graph of 5 minus x. Find the coordinates of point P. So this one is actually easier to do because we have a calculator. No, it's not easier to do. It's slightly easier because there's not fractions, I guess. It's about the same though. I don't know if I would call this a bonus question. The last one was a little bit harder. Enough talking, let's go. What is the slope of 5 minus x? Well, this has a slope of -1. If that has a slope of -1, again, the opposite reciprocal is 1. So we know that if I take the derivative of natural log of x, so I'll say that's, we don't have an f or a g, so I'll just say that dx, the derivative of natural log of x, I know whenever I take the derivative, it needs to be equal to the opposite reciprocal of -1, or it needs to be equal to 1. So where does that happen? Well, let's go ahead and solve, shall we? So what is the derivative of natural log of x? Well, it's 1 over x. So where is 1 over x is equal to 1? That's only when x is equal to 1. Well, we're halfway there, right? We want to find the x coordinate. Done. We need to find the y coordinate. Plug in the x coordinate into this function, and then you have it, right? Because y is equal to, let me change the color here. Y is equal to natural log of x, so therefore y is equal to natural log of, and I'm plugging in our 1 right here. And what is natural log of 1? Everyone should remember. Natural log of 1 is 0. It's just kind of a definition that you should know. So y is equal to 0, and we have our x and y coordinate. Let's write it in red. Our x coordinate is 1, y coordinate is 0. 1 comma 0 is our final answer. And that concludes worksheet 11-1.